Okay, also for Steve, how much GBR data is typically used in the design process for disc cutters?
Well, I'm going to turn that one over to Aaron.
Well, the GBR data is often used to predict cutter usage. We have a certain rock hardness where we specify a different type of material for the rings, but it's mostly useful for coming up with a budget and estimating total usage on a project so we can keep a job site supplied with the parts required to complete the tunnel.
Okay, and this question is for you, Aaron, on the remote cutter monitoring. How well does wireless communication work underground inside a TBM with all that steel around?
It actually works pretty well. That Niagara machine, 14.4 meter diameter, we had very little communication issues except on the very top of the machine where the hopper was located. But the attenuation of the wireless signal is not bad with all that steel around. And it was a good large size machine to try on, so we were very happy with the results.
Okay, also on the cutter monitoring, has a self-charging system been used for prolonging battery life for the cutter sensors?
We've not used it, but we would like to integrate something like that in the future. Just something that uses vibrational energy to generate the electric field, and that's something we're looking to develop in the future.
Okay. And also for you, Aaron, what types of vibration signals are you measuring? Is it acceleration or velocity?
It's acceleration in a 2-axis accelerometer.
Okay. And for Steve, in the next 10 years, what improvements do you think will be made in TBM cutters overall?
Well, what we're hoping to do is have a quantum leap forward similar to what happened 50 or 60 years ago when tungsten carbide was introduced to the mining industry. And that's kind of what we're after with this fast ton project that I mentioned earlier. So in 10 years, we hope to have materials and processes that will double the life of cutters.
And to go along with that, Steve, are there any limitations as far as ring steel or bearings?
Well, we really don't have a lot of control over the bearings. Those are all designed by the bearing manufacturers. Their designs advance slowly. They make very small changes. The life increases slowly, and of course, we automatically get that benefit because they're always making improvements to their bearings.
Okay, and this question is on pressure compensated cutters. I believe if the bearing seals are only rated to 3 bars, are the bearings then fouled above that limit? Are discs specially designed for higher pressures or for high pressure jobs?
Well, that's true. If the seal fails above 3 bar, then the bearings become contaminated and the cutter stops working in pretty short order. So it's absolutely necessary. You know, you're operating in an environment higher than 3 bar, and that you have some way to keep the pressure differential between the inside and the outside of the cutter at less than 3 bar. Ideally, we hope to develop a seal that doesn't have this 3 bar limitation. That's one of our development projects. But at the present time, what we're doing is using pressure compensation either with a piston or bladder to equalize the pressure inside and outside of the cutter.
And Steve, is there a maximum penetration rate or a typical rate for soft ground excavation with boulders?
Well, that's a hard question to answer. It totally depends on what the ground conditions really are, how hard the boulders are, how big they are. Boulders cause problems, and generally you have to slow down. If they're particularly hard, then you would be slowing down to the same rate as against a hard rock machine, say 15 millimeters per revolution of the cutter head, as opposed to 50 to 60 if you're in pretty soft ground.
Do we know which forces really act on disc cutters?
Well, there was an instrumentation done years ago, and sorry, Aaron.
No, that's okay. There was some measurements done, but we're trying to get a little bit more information in real time on the machine operating in every position. It's still a bit of a research project.
Okay, and I guess this one is for Steve. What kind of prediction tool does Robbins use for estimating tool life in rock, soil, and mixed face conditions?
Well, we have some software that we've developed over the years. It's an in-house proprietary calculating system that we've developed that over time, compared it to results, and tuned it so that it's pretty accurate.
Okay, and also for Steve, what are some measures that can be taken to minimize cutter wear in hard and abrasive rock?
Well, first of all, it's critically important that the cutter be attached to its mounting with properly torqued bolts, clean seats for the cutter to sit in. One of the problems we often encounter is the operators don't always enforce the rule that people changing the cutter should use proper torque wrenches and clean the cutter seat. So if the cutter is put in loosely, it will fail in fairly short order. It also damages the cutter head. The other thing that has to be done is to be very careful about making steering changes while you're boring. You don't want to overload your gauge cutters by making sudden steering movements. In a main beam machine, you want to make sure that the side supports are firmly against the wall and the roof supports firmly against the roof. It's a common misconception that the machine will bore faster if it's only loosely supported in the tunnel, but actually the cutter life will suffer unless the cutter head is stabilized very well.
Okay, and I think this is our last question for Aaron. Do you think that cutter monitoring systems will eventually be standard for all TBMs?
Oh, I think so. The benefit is so large that I think once the industry finds that it's available and accepts it and trusts the data, I think it'll be a standard part of every TBM.
Okay, so I think that's it for their Q&A.
Okay.
All right, thanks everyone for attending.
Thank you for joining us today.